began with circles, and well, the reason for that is because it links quite nicely into our next situation of loci. I've said now we should look at something that is related to two circles, one at the center A and one at the center B. We should describe 2 points and the locus of points between them. So you can see here, I've got 2 fixed points A and B, and I'm saying I'm looking for the locus of points that are always equidistant from A and B. So what would that be? Let's look at a point P. Let's say that it's equidistant, and we could say that perhaps that would be, say for example, right there in the dead center. Notice though that this would also work, and so would this. That would be completely equidistant between them. So would this, and I can go in the opposite direction to produce an image that looks something like this. Again, this is not to scale. I had to state that because of course my line is, you can see, is skew if, for want of a better phrase, but this would be our locus of points. And it is noticed that its phrase is that it's a perpendicular bisector A and B. And then there are 3 vectors that we can do something with in order to kind of map this out in the complex plane. I'm going to pick Z, Z1, and Z2. And what you will find is you'll find the following image. So first of all, I've picked a point P. I've gone, here is AP and here is BP. Here is my original locus. I've stated that there is this equivalence between them. And now what I'm going to do is I'm going to utilize the three vectors, or vector S. I should stay away from the phrase vectors because we are in a complex plane. Vector S positions of this. Now here is what we have. We have Z1 going to A. That is similar to what we had before. That is to say, if we can recall in this diagram, Z1 was going to A. We had Z going to this point P. Notice how in this one I have Z going to the point P as well. We have a third vector though, Z2 going to the point B. And so this allows us to consider the perpendicular bisector, or the points at which there is an equal distance from A to the line as there is from B to this line. Now this concept does have a relationship to circles, and I would like for you to consider that further. First of all, recognize that you could describe a circle with center Z1, radius AP, and that technically is manifesting itself here. That's what's manifesting itself here. You could perhaps also consider that, what if the center was B, radius was BP, and so the circle would also manifest itself here. These 2 circles would overlap to find, and the points at which they'd overlap would be, or the points at which you'd find a very interesting geometric pattern would match up very well with this perpendicular bisector. But that's not what I'm going to talk about specifically today. I just would like for you to consider that concept. What's most important is that we can utilize certain information. First of all, Z1 plus AP is Z. That is to say, Z1, if I go down Z1, then I go up AP, I have a position. Let's make this clear. My start position was the origin. I went to A because I did Z1. I then went up to P, so from there. And so because I started at this origin and ended up at P, it is the equivalent of Z. So I've said that Z1 plus AP is Z, and I would stick by that. I judge that to be true, particularly for these circumstances. Next situation, if I do BP, so I've gone from BP there, so BP. And if I want to do, well, you can say PB, it matters not in these circumstances. So if I want to do BP, and then I'm going to also have added this Z2. So Z2 BP, right? So Z2 BP, or PB minus Z2, whatever which way you want to consider it. If I go Z2 and PB, I've also moved to Z. Right, I've started this original point, I ended up at P, I've also done the equivalent beginning and end as Z. So I can say BP plus Z2 is Z. If I take the lengths of these, particularly, that's what matters most, is when I take the lengths of these, then the length of Z, I can rearrange this by the way, so what I've done is I've moved minus Z1 from both sides, so I'd have Z minus Z1, I've taken the lengths of these, I end up with AP. Right, just a rearrangement of that and requiring of the length. Here, I'm going to minus Z2, so I'm going to take this Z2, minus it to this side, so minus Z2 from both sides. I get Z minus Z2, the absolute value of that will give me the length for BP. And notice how these are very similar. The left side is very similar to radius equals Z minus Z1. Very similar in that sense. The radius equals Z minus Z1. The radius BP equals Z minus Z2. And this is something, again, that aligns us up with the concept of two overlapping circles, although that's not particularly what we're looking at. We're looking at the perpendicular bisector. I just want to remind us of that because I judge it adds an additional understanding and perhaps even some beauty to the circumstances. And what we're going to do now is going to take this information and find an equation that represents this perpendicular bisector.